This time our topic is angular momentum. Last time we saw only momentum, that means linear momentum. Linear momentum is the product of mass and velocity, and angular momentum is if my body moves around an axis. That means if my movement is in a circular path, then we call it angular momentum. What is the definition? Same thing of linear momentum times the distance from the radius or distance from the center or the axis. So we multiply here the radius only. So you can see here mv was our linear momentum. If we multiply the radius of the travel path, then it will be angular momentum. So again same thing, linear is mv, angular is mv times the distance from the axis. Then other term is angular impulse. Yeah, we learned only impulse, that was linear impulse, and our impulse was force times the time of application of the force. That means if a large amount of force acts on a body for a small amount of time, we used to call impulse. Now our topic is angular impulse. That means if a force acts on a body which is traveling in a circular path, then the impulse acted on it is called angular impulse, and that is force times the time, and then we will multiply the radius, and we determine it using a vector product. So again impulse was force time, and then angular impulse was force time time of application times the distance from the axis of rotation. So that is the angular impulse. Then what is the conservation of angular momentum and angular impulse equation? Similar to the linear we learn that mv1 plus f times t equals mv2. Same thing here, we will just add that radius of application. So if we apply radius of application, it will be m, this will be m v1 r plus, now the angular impulse, why it is moment, because if I go back again, so it is force times force times the time of application times the radius. So if we consider force times the radius, it will become a moment. So in short, we write moment times distance. So this is why it is moment times distance. Okay, so if I go down, and now again the conservation rule is initial angular momentum plus any angular impulse acting on it equals my final angular momentum. So this term will be m v1 r, this will be my angular impulse, this will be my final momentum m v2 r if my radius does not change. Okay, we will see an example now here. So this photo is from a kids park. So the supporting rod here is subjected to a couple moment of 10 t square. That means this rod is applying a moment, say this way and that way. That means it will rotate this sitting or this car will rotate, say that, oh no, it will rotate actually this way. That means this rod is applying moment this way, and it is a function of time, and determine the speed after 5 seconds. That means what is the speed after 5 seconds? If the car starts from the rest means initial velocity was 0, and mass was given 150 kilogram, lever arm 3 meter. That means here to here this radius is 3 meter. So what is our initial momentum? M b r1. Now last time I said both cases I said r, I didn't say r1 r2. I assume that because my radius is not changing, but it is possible that my radius will change. So m v1 r1, v1 was 0, so whole thing is 0. what is my final momentum, angular momentum, am v2 r2, that is the mass v, I do not know, so assume it is v, and my radius is r, so sorry 3, so total is 450 v. Now what is the angular impulse applied is integration of moment times the time. Now as it is a function, so we will do integration. If it is not a function, we could simply multiply it. So we will multiply from 0 to 5 seconds, 0 to 5 seconds. Then if we do the integration 10t square, so we will not disturb the 10, so 10 is here, then t power will increase by 1 and we will divide by the increased power, and then 0 to 5 equals 450 v. Why 450 v? We just calculated 450 v here. Then if we solve it, we will get our v is 0.93 meter per second. So very simple. We will see one more example here. This time what is happening, similar park equipment. Here we are applying a couple moment 12t, again function of time, and a force of 60. Now what is this force? So maybe the central machine, there is a central machine, I cannot see here, maybe somewhere here the central machine is applying some torque this way, and this individual track, it is applying a force this way. We are assuming, we do not know the exact scenario here, but we are assuming here that there is a central motor which is providing some moment and the individual car is applying some force. Now again, to what is n? N means Newton. What is n times m? That means Newtons time meter, which is a moment. Speed after 5 seconds starts from rest. That means initial velocity was 0. We need to find the velocity after 5. So same concept, but only addition is there's a additional force here. Last time there was moment only. So initial momentum am v1 r1 0, final momentum am v2 r2, so am v r. This time my mass is 200 kilogram and lever arm, that means the radius is 3, so 600 v. So if we take the impulse by the moment times distance, so we did the integration, and then the impulse by the applied force times distance times the time, so 60 times my radius, total is 18t. Again, if I apply different types of angular impulse, we have to add them together. So we added the impulse by the moment, impulse by the force. Then what we will do, same concept, initial momentum plus any impulse applied equals my final momentum. Then we did the integration 6, so it was 12t, so 12 we will keep it 12 here, t power will increase by 1, then divided by the increased power, so the 12 became 6. Similarly here 18t, so my power will increase t square, and then we will divide that 18 by 2, so it became 9. So that is the simple integration rule. Then equals 600 v. If we solve for v, now where t is going, we will insert the value of t5. I know that you know it from our very beginning. It's a simple integration. Then after solving, we will find the velocity. There is another example here, but this time I will not do it because it will take little longer time. In this example, what will happen, my radius will change with time. That means, okay, so I am not discussing this on now. So practice these 2 examples that I described, and let me know if you have any question. Thank you.